All right. Hey guys. So you just matched and organized and taped up your information for a synthesis reaction, a decomposition reaction, a single replacement reaction, and a double replacement reaction. We are going to just dive into each reaction type more closely, and then you're going to practice predicting the outcomes. Okay? All right. So our first one is the synthesis reaction. Again, just like you saw in the matching demo, a synthesis reaction is when reactants bond together to create one product. That doesn't look like the word create, sorry. Okay, so an example of this is sodium plus chlorine. They come together to make sodium chloride. And so how do we do this? We know that sodium, Na, has a +1 charge, and chlorine has a -1 charge. So we crisscross our charges. So we know that Na plus Cl makes, I think it's Cl2 actually. Yep. So we crisscross our charges NaCl. And now we need to balance. So we have NaCl, NaCl, Na is 1, Cl is 2, Na is 1, Cl is 1. I need to get my Cl to be a 2, so I'm going to put 2 out here. 2 times 1 is 2. 2 times 1 is 2. And then I'm going to put a 2 out in front. Okay? So we need to bring together by crisscrossing our charges. So step 1 is to crisscross charges. And then 2 is to balance. Okay? So a synthesis is when all the reactants come together to make one product. Okay? And you crisscross your charges to predict the product, and then you balance your equation to make sure everything is the same. All right, let's go do another one. Well, another reaction. Our next reaction is decomposition. Decomposition is when the reactants break apart or they decompose to form 2 or more products. Okay, so for instance, if we have NaCl, they break apart into Na plus Cl. The reason why Cl is Cl2 is because it is a diatomic atom, and all halogens are diatomic. Okay, and now we need to balance. So I have Na and Cl. There's 1 and 1. And then I have Na, Cl. I have 1 and 2. Again, we need to put the 2 out in front. 2 Na, distribute to Cl. So therefore, the 2 needs to be put in front of my Na. So I have Na2 and 2, Cl2 and 2. So again, I break apart, determine if it's diatomic. and then 2, you balance. All right, nice. Those are the easy ones. Now we're going to dive in deeper to do the more difficult ones. Single replacement. Single replacement is when the like atoms in the reactants swap places, leaving one atom alone or single. Okay, so I'll repeat that. The like atoms in the reactants swap places, leaving one atom alone or single. Okay, so here's an example. We have iron plus lead nitrate. What's it going to make? So when I say like atoms, I mean ones with the same type of charge. Okay, so iron, Fe, is a metal. It has a positive charge. Lead is a metal. It has a positive charge. NO3 is a nonmetal. It has a negative charge. Therefore, my like charges are my metals. So my metals are going to swap places. Iron is going to go hang out where the lead is, and lead is going to hang out where the iron is. So let's rewrite this. My lead becomes alone, and my iron hangs out with my nitrate. Okay, and to decide what charges they actually have, you get to reverse the crisscross. So you see this 2 out front of the NO3? That means that lead is not only a positive charge, but it's a positive 2 charge. Okay? Which means that there is that 1 by the lead. So if we reverse crisscross that, NO3 is not only minus, it is a -1 charge. Okay? So when we bring our iron with our lead, looking at the periodic table, we know that iron takes a +2 charge. So we crisscross them down. So that's why it's NO3 with the 2 on the outside and iron 1, because of the charges crisscross. All right? And now we need to balance. Let's rewrite this. So we have Fe plus Pb NO3 creates Pb plus Fe NO3 with that 2. Okay. And now we balance. So iron, lead, nitrogen, oxygen. Iron, lead, nitrogen, oxygen. Iron is 1, lead is 1, nitrogen is 2, oxygen is 6. Lead is 1, iron is 1, nitrogen is 2, oxygen is 6. Good, and we're balanced. So the same type of charge will swap, okay? So either if there are, let's write this up here, if they are two positive charges, they swap. If there are two negative charges, they swap. So the big deal with this one is look for the charges. Okay, next one. Double displacement. This one's my favorite. So double displacement is that the like atoms in the reactant swap places, making two new molecules in the product. So the like atoms in the reactants swap places to make two new molecules. All right, so let's look at this. So we have Li2, sulfur, plus AgN AgNO3. Okay. And that's going to make, so let's look. So I have lithium is a metal, so it's a positive charge. Since the sulfur has a 1 here, it is a positive 1 charge. Okay. Sulfur is a nonmetal, so it is a negative 2 charge because of that 2. So the red underlines the 1 for the lithium, and the reverse crisscross, the 2 is for the sulfur. So lithium is at a positive 1 charge, sulfur is at a...
Mr. Lopez, the main office. Mr. Lopez, the main office. Thank you.
Just making this video during conference time. So lithium is a positive 1 charge, sulfur is a negative 2 charge. Let's look. There is nothing on the parentheses other than a 1, so that means silver is a positive charge because it's a metal, it's a positive 1, and there's nothing after the silver, so that means that nitrate is a negative because it's all nonmetals. Nitrogen, oxygen are nonmetals, and it's a negative 1 charge. Okay, so I've got my metals, and I have my nonmetals. They are going to swap places. Just to give you guys a hint of how to do this easier, I always keep my nonmetals in the same spot and just fill in my metals. So that means lithium is going to go bond with NO3, and silver is going to go bond with sulfur. And now let's take their charges. So silver is a +1 charge, sulfur is a -2 charge, lithium is a +1 charge, and NO3 is a -1 charge. So let's crisscross those charges. So the 2 will come down to the silver, the 1 will come down to the sulfur, the -1 will come down for the lithium, and the +1 will come down for the nitrate, the NO3. Okay, so let's rewrite this. I have lithium 2, sulfur plus silver NO3 creates silver 2, sulfur plus lithium NO3 with the 1 outside. Good. Okay, and now we balance. We've got lithium, sulfur, silver, nitrogen, and oxygen. Lithium, sulfur, silver, nitrogen, oxygen. Lithium has 2, sulfur has 1, silver has 1, nitrogen has 1, oxygen has 3. 1 and then 3. Lithium has 1, silver has 2, sulfur has 1, nitrogen has 1, oxygen has 3. Okay, so let's turn my lithium into 2. So that's 2 times 1 is 2. 2 times 1 is 2. 2 times 3 is 6. All right, and then let's turn my silver into 2. Two times 1 is 2. 2 times 1 for the nitrogen is 2. 2 times 3 is 6. Let's look. I've got 2 and 2, 1 and 1, 2 and 2, 2 and 2, 6 and 6. Good. So again, for this double displacement, the like charges swap. Okay, the like charges swap. The like charges swap. And then you have to, so number 1, you swap. Then 2, you crisscross. And then 3, you balance. And you crisscross charges. All right, and then you balance. So 1 swap, 2 crisscross charges, 3 balance. And if you can't crisscross the charges, you need to reverse crisscross. Okay, those are our 4 reaction types. Good work, guys. You are now going to just go do tons and tons of practice. All right, good job.